All right, so this section, 5.8, solving rational equations, the key to doing these problems is that we have to find common denominators. So you're going to look at the denominators for all of the little fractions that they're showing you, and you're going to have to find common denominators for those fractions. As usual, I'm going to try working with even problems just because it gives me more room to the right, so it's easier for me to write more stuff. But we'll do these problems together. We'll try to do 4 of them. Notice how the fractions don't look too complicated, okay? They look pretty simple. Every once in a while you might see something with 2 terms on top, like you can see number 4, okay? 2 terms on one of the fractions. But notice it doesn't get too much more difficult than that, okay? So they're trying to keep it as easy as possible. But again, these are not the easiest problems, but they are the easier problems compared to some of the other ones. All right, so let me show you how to do this. The key is you finding the common denominator between all those denominators. Okay, so here we go. The problem that we have is 1 over x equal to 2 over 3x plus 1 over 3x squared. Okay, so let me just list all of my denominators. Okay, these are my denominators. For all 3 fractions, I have an x, a 3x, and a 3x squared. What do they all have in common? An x. Do they all have a number in common? No, right? But they all have an x in common. Now, I want to try to make, I don't know if you guys remember this idea from before, but it's called the least common denominator. And in order to find the least common denominator, here's the trick. You're going to take every variable to its highest power, okay? And you're going to take every number that's given, and maybe you multiply things together, but you're going to take every number together and combine them, okay? Now, if the numbers already match, don't do the same ones, okay? So, in other words, see how right here we have a 3 and a 3? I'm not going to multiply those together because they're both the same. But if there were different numbers, then I would multiply them together. Okay, now with the letters, I noticed there's an x and the highest power is an x squared. So I'm going to take an x squared. Okay, and I'm going to take a 3. For me, my least common denominator is a 3x squared. Because 3x squared can be divided by all those 3 denominators. X can divide it, 3x can divide it, 3x squared can divide it. Okay, again, how did I get 3x squared? I said, okay, let's look at the numbers. What numbers do they have? Well, they only have a 3, so I wrote 3. What about the letters? Well, they have an x. What's the highest power? X squared, so use that. Okay, now what do I do with this number? I'm going to multiply everything by 3x squared. Okay, so the reason why people don't like doing these problems is because if you show your work, these problems can get a little bit lengthy. I'm going to show my work as we do it because I'm going over this with you guys. You don't have to. You can do a lot of the stuff in your head if you want. Okay, now that's the way I do it. But before, this is what my work looked like. Okay, so 3x squared. Actually, let me not put a parenthesis there. I'm going to put it on the actual problem, 1 over x equal to 3x squared times 2 over 3x plus 3x squared times 1 over 3x squared. Now, if you're wondering, why the heck am I going to do that? It's just going to make my problem so much longer to do. Actually, what we're trying to do is get rid of the most hated part of math, which is fractions. We don't want to get fractions anymore. Let's get rid of our fractions. So we're going to try to get rid of them by multiplying by the least common denominator. Okay? So 3x squared times 1 over x. You guys remember you can cross cancel, right? We've been doing that. So notice one of the x's will cancel with that. Okay, I'll have x to the first right there. So I'm left with 3x. That's what's left over on the left side. Notice no more fraction. Okay, the next one, the next fraction, 3x squared times 2 over 3x. Well, look, the 3 will cancel with the 3, and one of the x's will cancel with one of these x's, so I get x times 2. I'm just going to leave it like that just for now. Okay, if you want, let me write over here 3x times 1 in case you want to see the step. I'll show the step. Okay, so all that's left is x times 2. Again, notice fractions are gone. And the next one, the 3 cancels with the 3. The x squared cancels with the x squared. So the only thing left is a 1. If I simplify what I have right there, this is 3x equal to 2x plus 1. Doesn't that look way easier to solve than the original thing that had tons of fractions in it? Right? Now all I got to do is subtract 2x on both sides, and I'm done. X equals 1. And that's it. The key to these problems is that you get rid of the fractions. The way you get rid of the fractions is by multiplying by the least common denominator. Okay? The way you get rid of the fractions is you multiply by the least common denominator. When you do that, you're going to start cross-canceling things, simplifying, and you're going to end up with just a normal-looking equation. Then you solve. Okay? Something that you're kind of used to solving. Just a normal equation. All right? So you have 8 of these types of problems. We are going to kind of do 4 of them, like I said. So here's one of them. So let's look at another one. Yeah, let's look at another one right now. And then if you guys have any questions on this, we can look at that. So 1 over v squared equals v plus 2 over 5v squared minus 1 over 5v squared. Now I'm going to do the same thing I did with the other problem. I'm going to list all of my denominators. V squared, 5v squared, 5v squared. I want to find their least common denominator. So you start with the numbers. And you say, well, what numbers do I see? Well, I see a 5 and a 5. They're the same. So therefore, the least common denominator will be a 5. Again, if there's multiple numbers, then you get to multiply them. But there's not a bunch of different numbers. It's all the same numbers. And then for the letter, notice how they're all v to the power of 2. So v squared. If one of them was a v to the power of 4, then you would have picked v to the 4th. Okay, you always pick the letter with the highest power. So I'm going to multiply everything by 5v squared. So 5v squared times 1 over v squared equals 5v squared times v plus 2 over 5v squared minus 5v squared times 1 over 5v squared. Again, that's usually the long part of this problem. So let's start cross-canceling. What can I cross-cancel over here on this side? The v squared. Okay, so here we go. V squared, v squared. All that's left is 5 times 1. I'm just showing the step, okay? What can I cancel on the next one? 5v squared, all of it, right? So all that's left is v plus 2 minus, what can I cancel on the last one? All right, so all that's gone, so it's just minus 1. Way easier than the way it started. So this is 5 equal to v plus 1, right? Because 2 minus 1 is 1. Just subtract the 1 on both sides. So we get 4 is equal to v. Are we okay with that? Any questions with this one or the previous one? Now, there's something I haven't talked to you guys about, which they call extraneous solutions. So let me write this down really quick. And then we're going to talk about it for the first two problems. Let me put it right here. They're called extraneous solutions. These are numbers that make the denominator equal to 0. A denominator should never be equal to 0. Okay? But sometimes when you look at a problem, you're like, ooh, I can't use that number, or else when I divide, it's going to be a 0. Right? Those are called extraneous solutions. Okay? So you're going to have to know how to find them. And they're not hard to find, just so you can see. At least not in these problems. They're pretty obvious most of the time. But let me show you. If I look at this problem right here, okay, look at number 2. See how that we have like an x here and a 3x there, a 3x squared, right? What number should I never use for x, or else everything messes up? 0, because if x equals 0, don't I get 1 over 0, 2 over 0, 1 over 0 again, right? Like all the way across. If I plug in a 0 here and a 0 there and a 0 there, everything on the bottom is going to be 0, right? And that's not good. I can't have zeros in my denominator. So I would say, if they ask me, though they right now they ask us to check for extraneous solutions on the very top. You see that? Check for extraneous solutions. All right, they're basically saying what number will mess this up. So for number 2, you're going to want to say x should not be 0. Okay, now granted, on your homework, you're not going to have to write that down, but I'm letting you know on your quiz, they're going to ask you, what numbers should you not use? Okay, I should not be using x equal to 0 here. What number for number 4 should I not be using? 0, right? Again, these are kind of gonna all be the same, because remember I told you these are the easier problems, but when we do this stuff tomorrow, that's gonna change. Okay? But right here, you don't want to use v equal to 0, because if you let v equal to 0, then everything's gonna get divided by 0, and we're not supposed to divide by 0. Okay? So that's number 4. All right, so let's move a little quicker with 5 and 6, okay? Or 6 and 8, sorry. So let's just get it out of the way. What number should I not use here? 0, right? Now, you're kind of getting the pattern for these right here. That's why we didn't ask you to tell us, because we knew it's always going to be the same number. Okay? But let me rewrite this problem. 1 over 2p minus p plus 1 over p equals 2 over p. I'm going to write down my denominators. 2p, p, and a p again. What number do I use for my least common denominator? A 2, right? I know they don't all have a 2, but remember, the key is list all the numbers that are there. They have to be different, though. If there was a 2, and a 2, don't write it 3 times, just once. Okay? But there's only a 2 there, so I'm going to write a 2. The letter P is my next one. What's the highest power that we see for the letter P? First power, so then just 2p. That's my least common denominator. Okay, so let's multiply everything by that. So 2p times 1 over 2p. So you can kind of understand how I mentioned earlier. If you can do it in your head, feel free. You don't have to write out this step. I'm just writing this out in case somebody needs to see what I'm doing. Okay, so everybody works at a different pace. So if your pace is a little faster, then go ahead and work at your own pace. So there you go. What do I cancel on the first fraction? 2p. So 2p, that's gone. All that's left is a 1 minus. What do I cancel on the next fraction? Just the p. So this is going to be 2 times p plus 1 equal to, and what do I cancel on the last fraction? Just a p, thank you. So it's just going to be 2 times 2. So let's simplify. 1 minus 2p minus 1, minus 2. Don't forget to distribute that negative that's right here. Okay, that's going to have to go to both of them, okay? You want to make sure that you send that over to both of them. And that's equal to 4. So if we just keep simplifying, 1 minus 2, that's negative 1 minus 2p equals 4. And add 1. So now we're just doing what you basically learned in Algebra 1. Right, negative 2p equals 5, so divide by negative 2. So p equals negative 5 halves. And we should have, yeah, you can see it's part D right there. So here's your answer. So I'm going to let you guys do number 8 on your own, and then we'll check it. All right? Let me show you number 8. Now before we go into this, what number can n not be? Yeah, so again, it's kind of ridiculous to ask you here because it's always going to be 0, because the easy problems always have a 0 as non-usable. The harder problems, not always. So those are a little different. So n cannot be equal to 0. And what else here? Yeah, so go ahead, start working this one out. I wrote the problem up there for us, right? 5 over 4n equals to n minus 2 over 2n minus 1 over 4n. I'm going to write down my denominators here. And I just want to write my least common denominator. Now, we see a 4, a 2, and a 4. And I told you guys what you could do is you find all the numbers that are different and multiply them out, right? So 4 times 2 would be 8, correct? The best number to actually do, your LCD is actually 4n, but if you use 8n, it's still okay. All right, now how is it that it's really 4n? Well, it's because 2 goes into 4, so you actually don't have to list it. But that starts to get a little complicated. So I always tell people, instead of worrying so much about what fits where, just go ahead and multiply the numbers, right? A 2 and a 4 become an 8. So just do that. That's fine. Okay? No big deal. And the n, it's n to the first because they all have an n to the first. So there you go. Now I'm going to multiply everything by 8n. Okay, so 8n times 5 over 4n equals to 8n times n minus 2 over 2n minus 8n times 1 over 4n. Now we're going to have to simplify, okay? All right, so sorry about that. So I'm going to move this thing up here. I'm going to cancel, okay? So the n will cancel with this n. And the 8 divided by 4, they're actually going to reduce. This is going to become a 2 up there. So that's going to become 2 times 5 equals 2. This n will cancel with that n. This 2 will make that a 4. So that's going to become 4 times n minus 2. And then on this last part, this n will cancel with that n. And the 4 will reduce the 8 to a 2. So that becomes 2 times 1. So notice when the numbers get bigger, sometimes when you cancel them out, they actually leave something left over. Here we had like a 2, a 4, and a 2 show up. Okay, which is okay. Now 2 times 5 is 10. This will be 4n minus 8 because you got to distribute, right? You're going to go this way. And then minus 2. So let's just simplify here. 4n minus 10. We'll add 10 to both sides. So you get 4n equals to 20. And if you divide by 4, you get that n equals to 5. All right? So that's today's lesson.